Hello everyone, welcome to Practical Lab 3, the Transformer Lab. Now as you all know, my name is Pamelo and today I'm just going to be walking you guys through some of the basics you need to know when performing Practical Lab 3. Cool, now before we actually start with the actual lab, you guys probably need to know where the machines lab is located. Now it is located in room 334. Now as you come past Green Lab in Menzies, many of you might be tempted to go through the first entrance. Please don't, it's actually locked. We need to use the second entrance. Come with me. Cool, now before we actually enter the lab, there are a few rules you guys need to be aware of before entering the lab. Some of which include no open shoes are allowed, meaning you have to wear closed shoes, no food or drinks inside the lab, and please do not touch any exposed wires. You will get shocked. Cool. Amplified. Okay, so for today's lab, we're going to be using the generalized setup, which can be used to test various electrical machines, which includes induction, synchronous, DC, as well as three-phase and single-phase transformers. Cool, so for today's setup, this has been configured to test for transformer. We're going to be using the two power meters, the HMI, human machine interface, an AC supply, single phase, as well as with the variac to control the AC drive. Starting off with the current measurements, the first button cycles through the three different current readings, which include the current demand, maximum current demand, as well as RMS current. Please note, we are interested only in the current RMS current, so ensure that your blue indicator is under the amps section. So for the voltage readings, we're going to be using the second button, which is going to show us our frequency as well as our voltage readings from our transformer, which is indicated in the second and first column. And moving on to the power readings, this also is quite similar to the current, where we're able to measure our demand power, maximum demand power, as well as our RMS power units. Please note that we are able to see our real power, our reactive power, as well as our apparent power from this power meter. We can also measure our power factor by using the same third button. Now moving on towards the HMI, human machine interface. This is used to configure the different setups of our lab tests through some of the PLCs in the background, programmable logic controllers. So as I mentioned, this is a generalized setup, which means that we are able to run various tests, including AC lab drives, induction tests, as well as the synchronous machines. But for the purposes of this lab, we're going to be using the transformer setup. So if you click that button, it'll lead you to the transformer test. Now for this lab, we're going to be going through three tests, which include open circuit test, short circuit test, as well as the efficiency test. Now the nice thing about this HMI is it does give you a set of instructions that you can follow as you go through the lab, and there's also the contactors there, so if you press the button, it'll light up indicating that you have closed the circuit or opened the circuit, and if it's ready to be done. Now as you can see from the physical device, from the top level, this is our transformer, starting off with our primary side, which is the 120 voltage on this side, which has the black and white wire, and our secondary side, which is the 230 voltage side, which has the black and the red wire. Now these connections are shown over here, being the primary side and the secondary side. The secondary side is connected to our output meter, which is the power meter 2, and then our primary side is connected up through our input, which is through the power meter 1, which goes to our AC source, which is controlled through the variac. Cool. So for the last part of our lab, we're going to be looking at our 500 ohm resistor bank, which we're going to be using in our efficiency test. Now this resistor bank has 500 ohm resistors connected in series within the inside, and as you move your connection terminal along the various terminals, you'll be reducing your resistance. So in the first position, you will have a 500 ohm resistance. If we move it to the second point, you'll have a 400 ohm resistance. Third point, 300 ohm resistance. Second point, 200 ohm resistance. Now, this is connected to our second power meter, which will measure our output as it's connected to our load. Now, please make sure as you cycle through the various terminals of the resistor bank that you set your variac to 0 and that your contactor is off, meaning it's showing a green light. Please just read through the steps there, but the tutor will make sure that you're following the right thing. And that was it for our lab. Thank you guys for joining me in this video. Please like, comment, and subscribe. No. Moving on towards our safety section, we have different layers of protection which aims to protect the user from any electrical fault. Starting off with our first level being our circuit breakers, which will trip in case there's any current fault. Our second layer of protection being our isolator, which will be triggered if the switch switches off in case there's an emergency. This will trip, isolating our setup from our mains supply. Now our second layer, or the other layer of protection being the main isolator, this is typically used to turn our device on and off. And finally, our last but most important being our emergency stop. In case there's any emergency, just a quick press of this button will ensure that the entire setup is isolated from each other. And thank you.